Hello and a warm welcome back. Today on the bench is this bloody tech transformer which is taking an age to wind. The primary is finally on, although I did nearly screw it up badly. As you can see, I've drilled lots of holes into the sides of this bobbin where all the terminations come out. Some of them aren't quite big enough though, like in this case, to put a bit of sleeving through there to protect the wire as it comes through the bobbin. Although with this being FR4 it shouldn't really make a difference. And so, like an idiot, which I've done like a few times, I got the drill and tried to drill this out. Well, I did drill it out, slipped with the drill and nicked the bloody turn that was on here. I thought, well, that means I've got to take off the layer underneath and then those turns there to complete the primary. However, I just stripped some of the insulation off, managed to take off about one turn, rejoin the join as it were, and then just put another turn on top, so it didn't turn out too bad. Now I need to put on the screen, which is a copper foil which goes the width for the bobbin as it were. The original, as you can see, is a bit more substantial than this crap cheap stuff that you get online. I really need to get some decent stuff. This has got like a sort of bit of a paper backing and everything, but it's still more substantial, thicker copper than what I've got. So I'm just going to have to use what I can. If you have a primary secondary short, what your primary will do, will try to shove all that current into the secondary. It'll be like a very low impedance, and so what happens is, if your screen will take the full current, the full fault current as it were. So you need something a bit more substantial than this crap. But as I say, this is all I've got just for now, and I'm not going to bugger about getting some online, so it is something to be aware of in the future if you wind your own transformers, mains transformers, because obviously output transformers don't have a screen. That's the screen on, soldered wire, all cushy, see that there. However, I just noticed this is the join where I joined the, I don't know if I showed it in the last video, I had to join on a bobbin that ran out onto another bobbin of wire. And just looking at that, don't know if you can see that, that looks potentially like a short between the primary and this screen. I had a potential leak between this screen and this join here where I joined the two ends of the primary onto each other. I intended to test it with my AirMech Type 251 ionisation mega tester, test it at very high voltage. However, it seems to be playing up. I've also noticed that my variac is starting to be creaky. We've had so much rain recently that the bloody humidity is through the roof. Anyway, so in lieu of that, what I've got is my voltage doubler capacitor leakage tester. So what I'm going to do, I'm going to turn the voltage up. If we've got any potential short between the screen and the primary, then we should see some movement on this meter, which is configured as a current ammeter, and this is a voltmeter. At some point though, I'm going to have to take that off because obviously it will affect our reading. Anyway, I've also got the lamp limiter engaged just in case we do get a really bad potential short. Okay, so we've got 670 odd volts there, and that's showing no leakage. However, it is on the higher amp setting of the meter, So I'll knock that back down. Right, the voltage has dropped. Let's bung it on the lower current setting. Right, well the voltage has dropped and I've dropped it onto the lower current setting. Anyway, here we go again. 2, 3, 4, 600 volts. And we've got, what's that? 61 micro amps leakage. I don't know what that equates to. Well, it should be pretty easy, shouldn't it? Let me go and work that out using Ohm's law. Idiot, I forgot to take the blinking meter off. 600 volts, 60, look, 608, 609. You twig? What this is reading is the voltage meter impedance resistance. Yeah, it's DC, so it's resistance. If I take the voltmeter off, that should drop. Oh, I've fallen for that one before. It's so bloody easy to make mistakes if you're not careful. So as you can see, at 600 odd volts, what we had, we've got bugger all current going in there. Therefore, the leakage between the primary and that shield is okay. What I did to try and fix that was to put a bit of Nomex across the side there, also a bit going underneath the screen and whatnot. I also used a bit of DMD insulation, more on that later, underneath that joint as it were, and then I put quite a bit of epoxy on there as well, which is just starting to dry. So I think we should be right. So now I just need to fix me blinking AMEC ionization meter so that we can test it properly, but I'm pretty confident that we're okay. Oh, I don't know, you just get one thing sorted and you've got another 5 jobs come along. Oh well, c'est la vie. So next we need some 25 gauge or 0.45 millimeter, and we need to put on 9 turns. I've marked all the converted all the millimeters to AWG just to make the process a little bit faster. Hopefully this one will go on, this layer, this winding will go in alright and will take up far less space on the bobbin. That's 37 turns on there. The winding isn't 100% perfect. We've got a gap there, but I'm never going to achieve 100% perfection, so I have to be accepting of that fact. So what I'm doing, really ought to wind this with you in the bleeding way. I've got the tension on the wire, so I'm just winding it, I don't know, about 5 turns on, and then just trying to right, that should have made up for those false counts. And then trying to then use me stick just to punch them up properly. I'm not putting a lot of tension on there. I'm using my finger to put some counterbend, as I mentioned before. So as you can see, like, we've got a gap there. And knock with the old stick, and we're good. The problem is when you come to this other side, because if we're not careful while I'm going backwards and forwards, just trying to get the lay right, it can give a false count. And then as I go along, yeah, you see here, no you can't, as I go along I'm trying to watch out for cross turns, and I've got one here. Oh joy. Just bung a bit of a so I'm going to have to take them off and start again, those few turns. Mind you, that is probably because you're in the bleeding way, so it's your fault. Anyway, onwards and upwards. I'm a bit happier. Oh man, that is just things like this just drive me nuts that aren't right. I'm going to just continue on and slowly catchy monkey. That's the first HT layer on. Not absolutely 100% tip top brilliant, but that's none too shabby, I don't think, for hand winding. Yes, I think if you can see, if I just drop you down a tad, alright. There. As you can see, we've got a dip here. It sort of rises a bit here, and then we've got a dip here, hence like the turn sort of having a gap there. Not much I can do about that, apart from filling it in with sort of a bit of a thicker winding, like say maybe a heater winding or something like that. But yeah, I don't think that's gonna work exactly. The other thing I did think of doing is to wind a few turns on of the HD, wind back and then wind back. However, that throws our calculations out. We've got 134 turns. If we get it if we get another 134 on, that will give us 268. We need 209, 210, let's say. What does that leave us? That means we've got 42 turns over our other layer, as it were. There's going to be more than 42 if I go not going to work. So we're just going to have to hack it, I'm afraid, and maybe try and make that up a little bit further, you know, when we've had more windings. I'm still really worried about our window. It's disappearing fast. Yeah, really freaking out about that, but not much I can do really. Just keep on going. Just keep swimming, as the little fish said. So I'm continuing on with this. Said so again, apologies. Just trying to concentrate on guiding the wire with me thumb there. So I don't know if you can see, I can't see what you can see. We're getting me turns so they're close. We'll just go past this next count. Right, put it on brake. Hopefully you can see that we've got like a gap there, so I'll just use this bit of kindling just to shunt them up. You've got to be careful you don't screw the job up. Take my brake off, go around a tad. So we've got, hopefully, oh, bloody no, this screen is crap. We've got a gap there, I've got a gap there. It's not always possible to shove it up. And then we've got another one here. Usually with a bit of prying you can get them neater. As you see, I'm using my thumb to guide the wire on. It more or less winds itself. What I'm trying to do though is just put a bit, I'm putting a bit of pressure on there so that when the wire goes on it's got a sort of bit of a bend on it, so hopefully it will seat better. And if I've got like a sort of thing like that there where it's not quite seating right, I'll use the old fingers, and if the fingers don't budge it all up, just get me stick. It's amazing what you can do with a stick. This is the tricky bit, getting towards the end. The ends are always sods, but your fingers sort of get in way of the bobbin, as it were. Little tip, if you're doing a bobbin like this and you've got all your terminations at one end, then do all your like terminations, you know, your joins of your tape and everything at the other end, because the, let me just get my brake off, with all the terminations coming out this end, this is going to be quite thick. So if we can do all the joints of a tape this end, then that sort of evens things out a bit. If we were to do them all this end, this would obviously make this a lot thicker. Getting the tape to actually sit lovely all the way round and flat is nigh on impossible. You're going to get crinkles and all the rest of it. I tried my damnedest to do it, but you're going to get them, which yeah, is a pain, but there we go. One of the other delights of transformer winding is obviously while you're trying to stick tape on, you've got to muck about with a bobbin, and then what you get is this, and worse if you're not careful. So it's all just being a right royal fucking nuisance to sort out. So I'll do that, smooth it out. So I'll just use my fingers to try and get those kinks out, because you do not want kinks. So now that's ready to start winding again. We've got, where are we, 217, we've got to go to 259, well let's call that 26, let's call that 2. So we've got about 40 turns to pop on, and then we're done with that. And then what I'm going to do, I'm probably going to deviate from the winding plan of the original, and I think there's like a 57 turn winding somewhere. I'll have a look in a minute. I'm going to pop that there, and then hopefully we'll get rid of this divot. It's also a good job we haven't got many to go, because we're running out of wire on the old bobbin. That's the termination of the first high voltage winding, just temporarily taped in place. And then next I'm just going to use some super glue and pop a bit on this bit of heat shrink tubing just to secure it on the bobbin. can get the damn stuff to come out. It's a bit viscous. It's probably not been stored. I haven't stored it in the proper conditions probably, so right, pop that in there. Just stop that coming out. Next I'm going to use a bit of this thin Nomex just to put some insulation around there. Just mark it. That's the first high voltage winding terminated. Next I'm going to try and fill in this little divot here, and I think we'll cut it there because it's about 20 minutes long. Thank you all for watching. Take care of yourselves. Ta-ra for now.